Hi, today I'm going to go through finding the derivative using the chain rule. So first of all, I'm going to do an example where we use the formal setting out. There will be occasions where you need to do this, but then I'm going to show you how to do the derivative by inspection, which is how you will end up doing it most of the time. But let's start with this example here. We've got y equals 3 bracket 4x plus 2 to the power of 5. Now, the reason we're using the chain rule for this is because we have a function inside a function. Basically, that's the gist of what the chain rule is all about. So notice 4x plus 2 is like a linear function. And then if we think of the 3 times the brackets to the power 5, that is another function again. So what we're going to do is start by saying let y equal 3u to the 5. So what we're doing is we're identifying what's the inside function, in this case, the 4x plus 2, and we're using a substitution and letting that equal u. So I'll just say here where u equals 4x plus 2. Now, we want to find the derivative of each of these individually. So we've got dy du. So this means the derivative of y with respect to u. So here, just using our x to the n rule, bring down your power. 3 5s are 15 u, and we take one off our power. Then we want to find the derivative of u with respect to x. It's just going to be 4. Okay, so over here, this is where our rule, there's a couple of versions on your QCAA rule sheet, but this is probably the easiest one to work with and the most useful, I think. So we have the derivative of y with respect to x, because that's what our original function was, y in terms of x, is going to be equal to the derivative of y with respect to u. Now we've just found that over here. So we'll go 15 u to the 4 times derivative of u with respect to x, and that's what we've got here, 4. Now all we need to do is tidy that up, simplify it, and put our u back in. So 4 15s are 60. Our u was 4x plus 2. And there we go. That's our answer. Now, there are occasions where it is really useful to set it out like this and use that rule. But most of the time, you want to do it quickly, and you won't always need to do the full setting out. So this is when we call it finding the derivative by inspection. So what's important here is being able to identify what's the inside function and what's the outside function. So like we did with the formal way we set it out, we'd let u equal that 4x plus 2. So we're just thinking that is our inside function. And so the brackets to the power 5 is our outside function. Now, when we think of the formal rule, really what we have here, the dy du, you can think of that as the derivative of your outside or outside function. And the du dx, well, that's the derivative of your inside function. So basically, when we're doing the chain rule by inspection, we're just thinking through this in our mind. So what I normally say to myself, if I want dy dx, I'm thinking derivative of the outside. So forget about the 4x plus 2 for a minute. Think of this as 3 brackets to the 5. So if I'm differentiating that, I'm still using my x to the n rule. Bring the 5 down, makes 15. You always keep your brackets the same, or keep the inside the same, take one off the power. Now I'm going to multiply by the derivative of the inside. So now I focus on what's inside, and the derivative of that is 4. Then all I have to do is tidy that up. So I'm just going to multiply the 4 times 15 to get 60. And there we go. We've got the same answer as we did here, but as you can see, it's a lot quicker than doing all that setting out. So what I'm going to do now is take you through some examples of that using different functions, and just showing you how we identify the inside and the outside, and how we can just do this differentiating by inspection. So have a look at this next example. We've got y equals 4e to the 3x squared minus 1. So here we have this 3x squared minus 1 is sitting inside the 4e. You can sort of think of that being the outside function. So now when I'm finding the derivative, just dy dx, thinking derivative of the outside. So 4e to the something. Well, e to the x stays the same when we differentiate it. So we basically keep all of that the same. We never change what's inside. Now I'm going to multiply by the derivative of the inside. So now I'm focusing on that, and I use my x to the n rule. So bring down your power, that'll make 6x. Then all I've got to do is tidy it up. So I'm going to multiply the 6 times the 4 and bring my x to the front. This looks a little bit easier to read when it's like that. There we go. So that was quick and easy. Let's have a look over here. So this time we've got y equals 7 natural log of sine x. So the sine x is sitting inside the log function. So 7L, the brackets, that's our outside function, and the sine is the inside function. So once again, just start dy dx is equal to, now I'm thinking derivative of the outside. Well, the derivative of ln x is 1 over x. So basically here, remember a constant can just sit there throughout that process. It doesn't affect anything, like the 4 didn't affect anything here, it just stayed there. So derivative of ln, whatever's inside, will be, just put little times, 1 over whatever's inside, which in this case is sine x. Now I'm going to multiply by the derivative of the inside. Derivative of sine x is cos x. And then I'm just going to tidy that up. Now, these can both come into the numerator here. So 7 cos x over sine x. There we go, done. Let's have a look at the next one. This time we have 7x squared minus 4x is inside, and our outside function is the sine x, the 5 sine. So once again, I'm just thinking to myself, the derivative of the outside. So the 5 just sits there. Derivative of sine is derivative of sine x is cos x. So in this case, sine of this goes to cos of the same thing. And then I'm multiplying by the derivative of the inside. So using my x to the n rule, bring the power down. I've got 14x minus 4. Now, because I have a couple of terms here, it's really important to put that in brackets. And then I'm just doing the tidy up, and I can just, I'll pop it in front here. Just makes it a little more obvious that it's not inside the cos, it's sitting outside. And there we go, that's done. Now here I'm going to show you how we can apply that derivative by inspection to a couple of harder ones, because basically with a chain rule, we can have as many layers, as possible. There's no limit to how many layers you can have. So just here's an example with 3 layers. So we go through that same process, but this time we just have three things. So our very inside function is this 4x. And the 4x is sitting inside this cos function. But that cos function is sitting inside this 2e to the power of that function. So if you work systematically and just start at the outside and work your way layer by layer in, then you won't go wrong. So the derivative of y with respect to x is going to be, so the derivative of the very outside layer. Remember, the derivative of e to the x stays the same. So basically this whole thing stays the same, times the derivative of our next layer, that's the cos. So derivative of cos is negative sine. We keep what's inside the same. Then derivative of the next layer, which is our very inside one, the 4x, and that derivative is 4. And then we just tidy that up. I'm going to bring my negative right out the front. 4 times 2 is 8, so negative 8. I might pop the sign 4x there and have e to the cos 4x at the end. Okay, there we go. Let's have a look at this last example. So let's identify our layers. The very inside layer is that 2x squared minus 3x. The next layer is this e to that. And then the outside layer is our 4 cos, and all that's inside. So once again, we're just going to start at the outside and work our way in. So derivative of cos is negative sine. The 4 sits there. So negative 4 sine, keep everything inside the same, times the derivative of our next layer. That's the exponential. So derivative of e to the x stays the same. So you just write that as is. And then last of all, derivative of that very inside layer, and that's going to be 4x minus 3. Once again, I've got a couple of terms I need to put it in brackets. Okay, just going to now tidy all that up, and I'll bring that bracket right in here with the negative 4. So I'll have negative 4x minus 3 sine e to the 2x squared minus 3x, and then times e to the 2x squared minus 3x. And there we go. That is basically differentiating using the chain rule by inspection. Hope you found that helpful.